Hi everybody. So I've received a couple of questions from students who are a little confused about how to generate the histogram when doing their inverse transform method. And so the questions are less about exactly how to get a histogram to work, but more about how to implement these inverse CDFs or quantile functions. So I just want to do a quick example of that. So I've got in Microsoft Word here, I've got a CDF, well almost all of a CDF that I've typed out here. So rather than, so if I look at this, I say, you know, it looks like a full CDF. And so just to kind of show you another one of these sort of equation editor tricks, because I notice that this CDF doesn't go all the way to 1, I realize I need to add another equation to this bracket here. So what I'm going to do, for one, I'm going to turn off this, this drawing here so that stops doing that. But what I'm going to do is go into here and right click and say insert equation after in this little matrix equation form here. And that gives me this, it pops up another little box here. And so I then can put in, you know, I want this to be 1 for all x that are greater than 1.6. And so then what's hidden behind the scenes here, I've used these ampersands. So I'm going to insert a couple of these here to create alignment to make it so that these things are properly aligned. And so there we go right there. So so I just included you know, put a bunch of ampersands in, and that's how everything got lined up. But the point here that I was trying to make is that when you've got one of these things, so you can get them if you go to if you hit Control Enter in the case of a Mac, or you get the equation thing up here, you can go under bracket, and then you find you can get like an f of x down here. If you were to select one of those, but you want to add more rows or delete more rows, you just have to remember that to right click and then say insert equation before, insert equation after, or delete equation. So those are things you can do that there. What I'm going to do though is I'm going to quickly invert this thing. So get rid of this equation that I just created, and I'm just going to copy this equation so I get all the ranges. And I'll do a quick little inverse because most of this, I think, arithmetic will be easy enough to do. So the first thing I need to do is decide which rows I don't care about. Well, I only want to inverse. So I'm gonna put a little to the -1 here. There you go. Look at that. To the -1. So F inverse, and then I'm going to change this X to an R. And so when I look at this, all of the rows of the CDF that are not invertible, I want to get rid of. So pretty much in a CDF, the rows that are not invertible are going to be the rows that are constant. So I don't care about this equation right here. So I'm going to get rid of that one. So I'll say delete equation. And then I know that's going to mean that I'm just going to change this to a square bracket, but I'm eventually going to get rid of this range because it's going to be in terms of R. I know a constant is not invertible, so I'm going to get rid of this row. So delete equation. I know this constant is not invertible, so I'm going to get rid of that row. Delete equation. So now I really only have 3 things that I need to worry about inverting. So what I'm going to do is I'm going to work on the R ranges first. And so if I look at this, and I'd say for this equation, when x is between -3 and 0, what will the output be? Well, so when you plug in x into here, -3 plus, oh, and I think I meant this to be 0.3. I'm sorry about that. So this is supposed to be 0.3. So when you do -0.3 into this plus 0.3, I should get 0. So I know my R range is going to start at 0, and then if I plug a 0 into this, I see 0 plus 0.3, and it's going to go to 0.3. So my R range here, R, is going to be from 0 to 0.3. And then, so now I've got to invert this thing. Well, if I set R equal to this, and then solve for x, then I should get an R minus 0.3. Now if I want to check my work, if I plug a 0 into this equation, I get minus 0.3, and that's the range I expected. And if I plug a 0.3 into this, I get a 0, and that's the range that I expected. So in the next row, I kind of do the same thing. I say I need to update my range first. It goes from 1 to 1.5. And in this equation, if I plug in a 1, I get 0.3 out. And if I plug in a 1.5, I get 0.8 out. So this R is going to go from 0.3 to 0.8. And this is going to be R plus 0.7 if I do the inverse. And I'll check my work, 0.3 plugged into there, and I get a 1, which is the low bound on the range, 0.8 plugged into there, and I get a 1.5, which is the high bound. So I must have done that right. So I've got this last range to worry about. If I plug in a 1.5 in as x, I get 3 minus 2.2, and that gives me a 0.8. So I'll just put that 0.8 there. And then 1.6 plugged into here. Well, 2 times 1.6 gives me 3.2 minus 2.2, and sure enough, that gives me a 1.0. So I'll change that to an R. And if I were to set R equal to this thing right here and solve for x, I'll take the 2.2, move it to the other side, so I'll get R plus 2.2 and the whole thing divided by 2. So this is just going to be R plus 2.2, and then that whole thing divided by 2, and if I hit space, it even makes it pretty printed there. So I'm looking like things are in pretty good shape right now. Okay. So I just did a little alignment stuff there. So there is my inverse function. So now I need to implement this thing in Excel somehow. All right, so let's bring up Excel. So I'm just going to put this on this side, and I'll put Word on the other side. All right, and then I'm going to say that I want my R column to be over here, and I'm just going to create a bunch of uniformly distributed random numbers between 0 and 1. And I do that just by typing equals rand, open parentheses, close parentheses. When I hit enter, I get a random sample between 0 and 1. I can drag that down, and I forget how many random ones I told you to generate for your homework, but let's just do 350 because that's where I am right now. So I did 350. Those are all random samples from 0 to 1. So now I need my x. So here's where a lot of people were confused, because what do you do when there's these 3 ranges? Some people say, do I generate 3 histograms? But that's not how you do it. You need to, this is all going to go into one formula, and you're going to use if statements to break this stuff up. So all I can say here is I can say if the random sample, and I just need to basically say, is it between 0 and 0.3? Now I know that the A column will never be less than 0, so I don't actually need to check that it's greater than 0. So I'm just going to say, is this less than 0.3? In fact, I'll do less than or equal to 0.3 because I use the hard square bracket. And if it's less than or equal to 0.3, then I implement this here. So I'll say, okay, then it'll be A2 plus, or A2 minus 0.3. Otherwise, in the else case, when it's not less than 0.3, it's got to be greater than 0.3. So I then need a new if to handle this case. So I can say, all right, if A2 is in this case where it's greater than 0.3, I actually don't need to check if it's less than 0.3 because I know I'm going to be in the greater than 0.3 case. All I need to check is it less than 0.8? So I'm going to say if A2 is less than or equal to 0.8, then I do this formula, which is going to be A2 plus 0.7. And then finally, I need another nested if here. You could say, I could do another nested if here and say, well, then I know it's not less than 0.8, so is it in this range? But because we know that the A column is always going to be between 0 and 1, I really have nothing else to check, so I'm just going to put this formula in here. But if I had even more conditions, then I would put those additional conditions as additional nested ifs, and this thing would just be a long chain of nested ifs. But instead, I'm just going to put this formula where I'll put in parentheses A2 plus 2.2 divided by 2. I close that parentheses. I close the other parentheses. I think that's everything. I hit enter, and that's good. Now, if I just fill that down, then I see I get a bunch of numbers. And if I did this right, if I just scan through these numbers, I should see no numbers less than negative 0.3, and I should see no numbers greater than 1.6. And if you look closely, they might get close to negative 0.3, and they might get close to 1.6, but nobody goes over. So that's a good sign. So I'm just going to pull this all the way down to that 350. Anytime now. We'll get there. I don't want to overshoot. I always go too fast and overshoot, and then it's awkward. All right, so now I've got my random samples. And if I was paranoid, I could even do something like, what is the minimum of the B column, and what is the maximum of the B column? And look, the minimum is almost minus 0.3, and the maximum is almost 1.6, which shows that I'm really in the right range here. So I think I might have done everything correctly. So that was just kind of a bonus thing. But how do I then take the histogram of this? Well, on the homework, I've given you all sorts of help on how to generate histograms in Excel. If you want to be adventurous, you can go under, I think, Tools and Data Analysis. And they actually have under here a histogram tool that you can play with to generate a histogram. You can also use if you generate your own bins, you can use the frequency. So here's the frequency data array bins array. So if you look up how to use frequency in Excel, you basically can define your own bins or bin barriers, and then you can pass in the data array. And then if you do one of these data functions, so you have to like shift command enter, then it will then generate all of the counts for all of your bins, which then you can use a column plot, a column chart to end up plotting as a histogram. So that is one way to do it, and all that's documented in some of the hints that I give. But I'm going to just try something else that's a little faster just to demonstrate the point. So what I'm going to do is I'm just going to copy all of my data. So not the column plus the header, just the data, the 349 rows of data. And there's a couple different ways I could do it. So I come from an academic discipline where MATLAB is valued. So I will do this example in MATLAB first. I'm just going to type x is equal to, and then an open bracket, and then I'll paste in those 349 numbers, do a close bracket and a semicolon, and now I've got this vector x. So over here you see it says x. And then MATLAB has a nice little histogram tool. I can type histogram x. If you have newer versions of MATLAB, if you have old versions of MATLAB, use the hist command, hist x. So if I were to do hist x, this is a function that was going to be deprecated, and I get something that looks like this. So I can also do that histogram x, and it's something to look like this. And so if I want to put them both together, I'll maybe figure 2, I'll put hist x underneath it. And so what you should notice when I use these different functions is that MATLAB chose a different number of bins for both of these. Okay, now they both are giving me a good idea. Like if I look back at my CDF, if I were to derive the PDF for this thing, then basically from negative 0.3 to 0, I have a constant density. And then from 1 to 1.5, I have a constant density. And then from 1.5 to 1.6, I have a constant density, but it's higher. And so if I look at these, I'm getting the feeling that I did things right because I have a chunk that are over here at 0 to 0.3 as expecting, and then I have another chunk that are over here from 1 to 1.6 as expected. But because they chose different numbers of bins and bin positions, then I get something that looks very different. So these two commands, so if I were to go help hist, for example, have the ability for you to play with the number of bins or the position of bins. So here in the old-fashioned hist, and they say hist is not recommended, I can just pass in the number of bins. So I could go up and say, well, when I did hist, give me at least 10 bins. And so now that it did, so maybe I'll say, well, maybe I actually want 15 bins. And so now you see things are broken up and I get a little bit more resolution. But because I only have those 349 points and they're divided among 15 bins, then there's a lot of randomness in between these bins. I still get the general feeling that I have a density of 1 and 1 at from this range, and then the range from 1 to 1.5, and then I get a sudden rise in density up to 2 from the range of 1.5 to 6. So this looks pretty good. So this maybe is passable, but I probably just need more data to get really a clean version. If I do help histogram, then I can find out that histogram also has a Histogram XM where it'll also do this same game. So if I pull up my histogram thing, so I'll do figure 1, histogram X, and I'll do 15 bins with the histogram command and see what choices it makes. And it makes similar choices, but you can see that even in the histogram command, these bins aren't exactly the same because it chose the centers in slightly different spots, but it's basically the same plot. So those are examples of these. Now, I would recommend, that you should probably do an X label and say like outcomes on the X label, and then a Y label and say frequency, and a title and say something like histogram of inverse transform output or something like that. Because all good engineering plots should be labeled. So that's that. And then if I was to copy this into Word, then I probably would do something like set GCA font size 15, and that increased some of the font size here. If I wanted to, I could even do a grid on. And so then I've got something that doesn't look too bad. So then I'll go edit, copy figure. And it'll take a second to copy. And then I'll go over into Microsoft Word, and I could then plot the histogram, and I could go through and do all the centering and all of that. So, and of course you should put text in between here in your homework assignment. I'm just showing you generally how to get these things done. Alternatively, if you don't like using MATLAB, there's lots of other choices you can do. I'm sure you've got your favorite stats program. What I'm going to show you how to do now, so I'm going to go back and copy those data again, because I just copied that plot out, so I need to recopy these back into the clipboard. So let's assume I didn't want to use MATLAB. So I'm going to show you a very different way to do it. So I'll just knock out MATLAB here. If I go to my web browser, I'm not trying to advertise for this company, but there are these online tools for doing some nice plotting that actually come out looking pretty clean. And so one of these is called Plotly. We just plot.ly. And I logged in, but, all right, so it's reloading here. But if I had not logged in, then I think it would have shown me a big box here that would have said create, and mine's up here. So I can say create, and I'm going to create a chart. And then it says what type of chart do I want to create, and I can go over under distributions. I can click on histogram. And then it's got a little column here, and I can actually just paste all those 349 values right into that column. And then for X values, I can choose that. And then Y values, well, it's a histogram, so that's all it's there. And then I can say that I can then go in and say I'm going to put outcomes as my X-axis, frequency as my Y-axis, and then up here I can say histogram of inverse transform output, something like that. And that is another way I can generate a histogram. Now I don't use Plotly that much, and so you can find out more about it than I know. There's probably a way to change the number of bins that you have in here. I don't know off the top of my head because, again, I don't really use Plotly, but I wanted to at least give it as an option. This is still looking kind of chunky for me, but again, it's probably 349 data points for this particular transform, given the variance here, is probably pretty light. So more data would make a better looking plot, but you get roughly the idea of what this plot looks like. You get sort of a density of around 1 here, a density of around 1 here, and then it jumps up to a density around 2. So it's still looking pretty decent. Now, in Plotly, you can save and share if you have an account, which you can feel free to do. The other thing you could do is both in Windows and on a Mac, and I think in Linux too, there are a number of good screen capture tools. So I can go into, for example, on a Mac, I can open up the Grab app and say Grab Selection, and then I will then select this nice histogram that Plotly has generated for me. For all I know, it's against their terms of service to do this. I don't know for sure. But then if I hit copy there and then go into my Word doc, I can paste it in, and there you go. It's a little big, and the text there is actually, it's a little small for me. I have a feeling if I go back into Plotly, so I'll get rid of this this old plot here. If I go back into Plotly, I have a feeling that there's probably some easy way that I can, like, so if you look under this, down this axis, these buttons here, and go under Style, I bet if I went into like Axes, and it talks about like the X-axis and all that, I bet I could crank up the font size. Yeah, it looks like I can. So, and I can do the same thing with the Y-axis, so it can crank up the font size. I guess I probably even could have done all, and crank both of those up to like 24. And there's probably a way for me to do that with the title as well. So yeah, titles, well, I'm sure there's a way to also adjust the title size. And it's probably, you know, maybe it's under annotation or legend, general, maybe general. There we go, general, that's right. So I'll go and I'll crank up the title size. So that's good. I wonder if under analysis you can do curve fitting and averaging, which is interesting to add. Under transforms, you can do little statistical transforms. It wouldn't surprise me if there's somewhere buried in here is how you change the number of bins in a histogram. I just don't know off the top of my head. But, so there I go. I made the titles a little bit bigger so I could go back into Grab. Capture, selection, could capture, take the screen capture of this thing. Go up to edit, copy that, go back to my Word doc, paste in that, and then now not only does it look better, or do the numbers look bigger, but if I make the figure smaller to be sort of a more appropriate size for this, I can now read the axes. Should probably have gone back in and done something similar with the actual numbers on the axes, and so again, I'm sure one of these has got something to handle the fonts. I mean, I see tick labels, so for like the tick labels, I can crank those up, et cetera, et cetera. So there, it looks like I've cranked up the tick labels on the X. I could guess I can probably also do those on the Y. So there, that would probably be even better. So there you have it. That is basically how you go from a CDF to a quantile function, an inverse CDF, and then how you take that and into Excel, and you turn that into these formulas, like this one right here. And then from those formulas, then you generate data that you can then go into a MATLAB or a Plotly or whatever and generate histograms. So I think I will probably, just as an example's sake, save this Excel workbook as well as this Word doc, and they will be up on the Canvas site along with this video, and hopefully that helps you out.